had that in radians and I looked at it here, I'd be having to break this up into 7 pieces, which it doesn't do very nicely, and I've already drawn it badly. So what I actually have is 1/7 of 180 when I think of it in terms of degrees. So it's just 180 degrees on 7. However, what I did to do that, you could consider, is by timesing the pi on 7 by the 180 on pi, according to the instructions I give in the textbook. So this method does work, what we're talking about. Of course it does, or they wouldn't teach it to you. But if you can keep going with the idea of visualization and all you have to actually put in the calculator is 180 on 7, you're getting your thinking the right way around. What if I had something like 63 degrees and I wanted to convert it back to radians? 63 is not a factor of pi, a factor of 180, so it's not going to come out clean. I can picture 63 degrees, it's about there, but it won't come in nicely. What we have to do is times it by pi and divide it by 180, which is the opposite version, and that will put us in terms of pi, so 63 pi on 180, and what we're saying is we're saying 63 1/80ths of our pi. Of course, it is easier to just do that, so don't lose that skill. When you're thinking about whether you want to times or divide, just think, I've got degrees, I want radians, so I've got to introduce the pi, so put the pi on top. I've got radians and I want degrees, I want to get rid of the pi, so put the pi on the bottom. Okay, last but not least, I'm just going to show you the exact value triangles. Hopefully you've seen these a few times by now. If I have a triangle that is cut from an equilateral triangle, then that would be 1 and that would be 2. And this would be 60 degrees, 30 degrees, and by Pythag, root 3. I can use this to find the sine, cos, and tan of 60 and 30 and leave them in exact value without needing my calculator. If I did it in radians, that 60 degrees was 1/3 of 180. That was 1/6. Remember this. 60 goes to the 3rd, 30 goes to the 6th. Okay, because when you're under pressure, it's quite easy to convert pi on 6 to 60 degrees. It's also why I get you to visualize it and put it on the circle and go, yeah, pi on 6 is little. It's only this big, it can't be 60 degrees. This one's 60 degrees. That's pi on 3. So now I can find cos of pi on 3, 1/2. Tan of pi on 3, root 3. Tan of pi on 6, 1 on root 3. You see, we can use this to find lots of sine, cos, and tan ratios very quickly. Just remember, this is the only version on your formula sheet, so you will have to do this little bit of conversion in your head, or even grab your formula sheet, write it on your formula sheet, and when you sit in the exam and they give you a fresh one, just write it in. Just write pi on 3 here so that you're not having to think about it at the time when you're under pressure. The other triangle comes from cutting a square in half, so that's 45 degrees. That's pi on 4, root 2 by Pythag. So the cos of pi on 4 is 1 on root 2. The sine of pi on 4, 1 on root 2. Tan of pi on 4, 1. So you can use this for all of those exact value ones, and then when we go and do angles greater than 90 degrees, when we're doing trig, or our angles greater than pi on 2, we can use the unit circle and find a whole lot more stuff exact without the calculator. And again, you can almost use the calculator for that, but of course they're going to ask those questions backwards where you can't. So learn the skill now. That's all I can say. All right, see you guys.